So now we're going to look at doing some problem solving with Pythagoras' theorem. And if we remember from the last video, Pythagoras' theorem is c squared. So the area of the square on the hypotenuse equals the area of the squares on both of the short sides. So c squared equals a squared plus b squared. So when we're problem solving, we're using the properties of shapes in order to help us to form ourselves a right-angled triangle and then use Pythagoras to work out the information that we need. So we're being asked to calculate the perimeter, so let's highlight that word, perimeter of the isosceles triangle. So the perimeter is the distance around the outside of the shape, so we're adding the three sides of the triangle together. Now at the moment, we've only got the base of our triangle, which is 30 centimeters. So we now need to work out what those sides LN and ML are going to be of our isosceles triangle so that we can add them onto the 30 centimeters. Now, we can only use Pythagoras if we've got a right-angled triangle. And you can see I have a right-angled triangle here, and I've also got an identical right-angled triangle on the other side. So my isosceles triangle, if I put it in the line of symmetry, gives me two identical right-angled triangles. So I can draw myself a sketch of a right-angled triangle, and I'm going to choose L, N, and I'm going to call the middle point X of my right-angled triangle. And I know that the height from the X to L is 8 centimeters. And I know that from X to N, if I've got a line of symmetry going through XL, then XN is going to be half of MN, so that's going to be 15 centimeters. So I need to go to my right angle and have a look and see, do I have anything on the opposite side? And no, I don't have any value there, and I'm going to call that X. So I know that I'm looking for the long side of my triangle. So putting it into Pythagoras' theorem, I know that x squared equals n squared plus L squared, where L is this side here, which is 15, and n is this side here, which is 8. So I'm going to substitute my values in. So x squared is going to equal 8 squared plus 15 squared. And that gives me an answer of 289. To get x on its own, I'm going to square root that 289, because that's the inverse process of squaring, is square rooting, and that gives me an x value of 17 centimeters. So if I go back to my original picture of the isosceles triangle, I'm going to write on that 17 centimeters for side LN. And because I know that ML equals LN, I'm going to write 17 centimeters on LM. So in order to work out the perimeter, I'm going to add 17 plus 17 plus 30, which gives me a total of 64, and my units are centimeters. So my next example is using the properties of circles. So here I've got a circle, I've got 2 dimensions marked on, x and y, and I've also got a chord marked on, and it's being labelled AB. And in the question, I'm being given some additional information. I'm being told that the radius is 15 centimeters, and the length of AB equals 24 centimeters. So I'm going to write that information on. So I know that a radius goes from the center to any point on the circumference. So if I draw a line from the center of my circle down to point B, you can see that I have drawn in a radius of 15 centimeters, and I've also created myself a right-angled triangle with height x and long side 15 centimeters. Now I know that AB is 24 centimeters. So if I draw myself a sketch, because we always like sketches in maths, of my right angle triangle, this is side X, which is what I'm looking for. My long side is the radius, which is 15 centimeters. And I know that the point from, if I call it M for the middle, to B is going to be half of 24. So that's going to be 12 centimeters. So now I want to use Pythagoras. So I'm going to go to my right angle. I'm going to go and draw a line. And I'm going to see I've got a value on that side. So that means I'm going to be subtracting. And it's the big square side squared, take away the small side squared. So I know that in order to work out x squared, I'm going to do the big side, so the side that I've just pointed to with my arrow, 15 squared, take away 12 squared. And that's going to give me a value of 81. And then I'm going to square root that 81 to get the value for x. And it's going to be 9, and my units are centimeters. Now, if I go back to my original picture and highlight xy, x plus y is going from the center to the circumference. So x plus y is also a radius. So I know that x plus y equals 15 centimeters. Now I've just worked out what x is, that's 9, so I can substitute that in. Plus y is going to equal 15. I need to take away 9 from both sides. And that gives me a y value of 6 centimeters. And so I want to answer the question, x equals 9 centimeters and y equals 6 centimeters. So what if we are given the dimension of x and the radius, and we're asked to find the length of the chord? Again, we have to make right angle triangles. We can't work out these things with isosceles triangles with Pythagoras. We have to use a right angle triangle. So in this circle, we're told that the radius is 34 centimeters, and we know that the radius is going from the center to the circumference, from the center to the circumference. So we can either use, if we call the center of this circle O to A is a radius of 34, or O to B is a radius of 34 centimeters. And we know that x, so from O to the chord, is 16 centimeters. And we'll call that point in the middle there M. So if we draw ourselves a sketch, we've got O, M, B. We know that the length on the hypotenuse, the radius, is 34 centimeters. And we know that x, the height of my right angle triangle, is 16 centimeters. And we're trying to work out what the length of MB is. So, marking my right angle, I'm going to get an arrow from the right angle to the long side. And I can see that I have a value on my long side. So again, I know I'm going to be subtracting. So I know that MB squared is going to equal 34 squared, because that's my long side, take away 16 squared. And that gives me a value of 900. And then I'm going to square root that 900 to get the length of MB. And so the square root of 900 is 30, because 30 times 30 is 900, and that's centimeters. Now, I know that from the middle of the line to B is 30 centimeters. So AB is going to be double MB. So to get AB, I'm going to have to do 2 multiplied by 30 centimeters. So that gives me a chord length of 60 centimeters. My final example is looking at a tunnel of radius 8 meters that has a road of width 10 meters running through it, and I want to find the height of the tunnel. So just because I haven't been given the entire circle doesn't mean that this isn't still a circle geometry question, because I can actually try to draw in the rest of that circle and mark in its center. Now, the question is telling me that I have a radius of 8 meters. So I know that any point from the center to the circumference is going to be 8 meters. And it's telling me that the road, so from one side of the chord to the other side of the chord, is 10 meters. So I can make my right angle triangle by halving that 10 meters. So if we draw our sketch, we've got 8 meters on the long side, we've got 5 meters on our short side, and we'll call the height of the triangle H. Now, let's go to our right angle. We'll draw an arrow to the long side. We've got a value there, so we know that it's a subtraction. So we've got H squared equals 8 squared take away 5 squared. And that gives us a value of 39. And then if we square root to get an exact value for H would be root 39. And I'm going to round that to 1 decimal place. So I get 6.2 centimeters. Now, if I go back to my picture, I know what this height here is that I've just calculated. So that's H. But I want the entire height of the tunnel. So we'll call that X. And I know that X is going to be H plus a radius. So if I write that algebraically, X is going to be H plus R. We know that H is 6.2. We know that R is 8. And if we add them together, we get 14.2. And our units is actually meters, not centimeters, because it would be a pretty small tunnel if it was only 6.2 centimeters.